Alright guys, welcome to the Law of Cosines. So we spent a couple videos looking at Law of Sines, and now we're going to be looking at the Law of Cosines. And we use the Law of Cosines to solve oblique triangles that deal with side, angle side, and side, side, side. So those are the two cases, okay? No ambiguous case here. So standard form of the Law of Cosines on the left, very good for finding missing side lengths. On the right, alternative forms, very good for finding angle measures. So I'm going to be using both today. So if I back out of the way and pause it, you can see, and you pause right now and copy those down. Okay, so these are the formulas that I'm going to use. I'm not going to run through them, but I'm kind of out of the way so you can see. Again, the ones in blue you want to use for missing side lengths. Okay, the ones on the right we're going to be using to find missing angles. All right, in our first example, solve the triangle A equals 2, B equals 3, and C equals 60 degrees. So we have a side angle side here, okay? So we're going to label our triangle 2, angle 60, 3, so side, angle, side. This is the law of cosines. So I'm going to start by finding the last side. So where do I start? Well, I could try to start with the angle if I wanted to, but I only know one angle, so it would be better to have all three sides so that way I can find the missing angles later on. And it's the easiest one to do. You can complete it, so we need to find that side C. So I go ahead and I know my formula for C here is C squared equals A squared plus B squared minus 2AB cosine of C. So now I substitute everything I know. A is 2, B is 3, A is 2, B is 3, and the angle measure is 60 degrees. Okay, now here comes the algebra. 4 plus 9 minus 12 times the cosine of 60. Cosine of 60 is 1/2. Make sure you multiply this before you subtract. Danger, okay? So be very careful on your order of operations. So I get 13 minus 6, which is 7. So don't forget to square root this. So I get C equals root 7 because C was squared at the beginning. So I found the final side. Now we're going to find the missing angles, and there's two of them. Fortunately, in this example, we only have to apply the law of cosines one more time because the final angle, we can just subtract what we know already. So I need to find the angle A. I just chose to find A because I know B, I know C, and I know A. I know all those terms. So the cosine of A equals B squared plus C squared minus A squared, all divided by 2BC. That's one of our alternative forms of law of cosines for an angle. So I go ahead and substitute. My B is 3, C was root 7, which we just found, and A is 2. Okay, substitute B and I substitute C here, and I get 9 plus 7 minus 4, all divided by 6 times root 7. 2 times 3 times root 7, which is 2 root 7 over 7. So in order to find the angle, I take the inverse cosine of this. 2 root 7 over 7, which gives me an angle measure of 40.893. Now, the only angle we're missing is B. I could go ahead and do the law of cosines again, but I don't need to. I already know two of the angles. So if I take the sum of those two angles and I take that away from 180, I get my final angle. So B is equal to 180 degrees minus A plus C. So those are my two angle measures. I take that away from 180 and I get 79.107 for the final angle. In this example, I have one not side angle side, but all three sides. Solve the triangle A, B, and C. Okay, so we need to find all three angles. It's very similar to the last problem, but instead of just doing the law of cosines once, I have to do it twice. To get two angles, and then I can find the missing third angle by subtracting the two I found from my 180 like I did before. Okay, so I need to find all three angles. I'm going to find A. Okay, A is first in the alphabet, so there's my formula for A, the alternative form of law of cosines. I plug in my known values for B, C, and A, which are 3, 6, and 4. Okay, and then I plug in B is 3, C is 6 times 2, and I end up, when I simplify this down, I get 29 over 36. So I know that the cosine of A is 29 over 36. I take the inverse cosine of both sides, so I get angle A is equal to 36.336 degrees. So that's one angle. Now I got to find another one. So I'll just keep going alphabetically and I'll find angle B. Cosine of B is equal to a squared plus c squared minus b squared over 2ac. So again, I plug everything I know in, and I substitute, and I simplify. So I simplify from here down, I get 43/8 when I square those numbers and multiply the bottom. So angle B is equal to the inverse cosine of 43/48, which is approximately 26.384 degrees. Now, the final angle is found by taking 180, and we're going to take away from 180 the sum of a plus b. I've already found two of the angles. So I take 180 minus angle A plus angle C, okay, which leaves me with 117.280. Now, don't be surprised, I've rounded to 3 decimal places if you add all three of these up and they're slightly under 180 or slightly more than 180. It depends on how you round, okay? So just be careful that we know that the sum of triangles, the angles has to be 180. So these two examples just showed side, 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 and side, angle, side for law of cosines, how to both find the missing side and missing angles. If you have any questions or comments, you can type them below, and we'll see you next time.